In mathematics, functions play a crucial role. They transform inputs into outputs. One-to-one functions hold a special place. Each input maps to a distinct output. No two inputs produce the same output. Imagine a vending machine. Each button gives a unique item. This uniqueness sets them apart. One-to-one functions have real-world implications, essential in cryptography, computer science, and data analysis. Their unique mapping ensures data integrity. Get ready for an exciting journey into one-to-one functions. To understand one-to-one functions, let's look at some examples. A simple example is f of x equals x. This function returns the same value as input. For instance, input 2 gives output 2. Another example is f of x equals 2x plus 3. Input 2 gives output 7. Each input produces a unique output defining one-to-one functions. One-to-one functions possess certain properties that distinguish them from other types of functions. One key property is their graphical representation. When we plot a one-to-one function on a graph, no two distinct points on the graph will have the same y-coordinate. This visual representation makes it easy to identify one-to-one functions. Another significant property is the existence of inverse functions. Only one-to-one functions have inverses. An inverse function reverses the mapping process of the original function. In other words, if we input the output of a one-to-one function into its inverse function, we obtain the original input value. These properties make one-to-one functions particularly useful in various mathematical operations. The existence of an inverse function, for instance, allows us to solve equations and find unknown values. By understanding these properties, we can effectively utilize one-to-one functions in different mathematical scenarios. While both one-to-one and onto functions describe relationships between sets, they differ in their mapping characteristics. One-to-one functions, as we've discussed, ensure that distinct inputs map to distinct outputs. This means that no two elements in the domain, the set of input values, can have the same image or output value in the codomain, the set of possible output values. Onto functions, on the other hand, focus on the codomain. A function is onto if every element in the codomain is mapped to by at least one element in the domain. In other words, every possible output value is achieved by some input value. To illustrate the difference, imagine a scenario where we're assigning students to classrooms. A one-to-one function would ensure that no two students share the same classroom. An onto function would ensure that every classroom has at least one student assigned to it. Understanding the distinction between one-to-one and onto functions is crucial for accurately analyzing and interpreting mathematical relationships. Section 5. Identifying one-to-one functions graphically. Graphs provide a visual tool for determining if a function is one-to-one. The horizontal line test offers a simple yet effective method for this purpose. To perform the horizontal line test, we imagine drawing horizontal lines across the graph of the function. If any horizontal line intersects the graph at more than one point, the function is not one-to-one. This is because those points of intersection indicate that different input values map to the same output value, violating the definition of a one-to-one function. Conversely, if every horizontal line intersects the graph at most once, the function is one-to-one. This visual confirmation aligns with the principle that each input value must correspond to a unique output value. The horizontal line test serves as a quick and intuitive method to assess the one-to-one nature of a function by simply observing its graph. Section 6. Applying the horizontal line test. Let's apply the horizontal line test to some examples to illustrate its effectiveness. Consider the function f of x equals x squared. If we draw horizontal lines across its graph, we'll find that some lines intersect the graph at 2 points. For instance, the line y equals 4 intersects the graph at x equals 2 and x equals -2. This indicates that the function is not one-to-one. Now let's examine the function f of x equals 2x plus 1. If we draw horizontal lines across its graph, we'll find that every line intersects the graph at most once. This visual confirmation tells us that the function is one-to-one. The horizontal line test provides a straightforward visual method to determine if a function is one-to-one. By examining the intersection points of horizontal lines with the function's graph, we can quickly assess whether the function satisfies the condition of having unique outputs for each input. This graphical approach complements algebraic methods for determining injectivity and provides a practical tool for analyzing functions. Section 7. Determining injectivity through algebraic proof. While graphical methods like the horizontal line test provide a visual indication of injectivity, algebraic proof offers a more rigorous method to determine if a function is one-to-one. The standard approach involves assuming that f(a) equals f(b) for some arbitrary elements a and b in the domain of the function. If, through algebraic manipulation, we can demonstrate that this assumption leads to the conclusion that a equals b, then we have proven that the function is one-to-one. This is because it shows that if two outputs are equal, their corresponding inputs must also be equal, satisfying the definition of injectivity. For instance, consider the function f(x) equals 3x minus 2. Assuming f(a) equals f(b), we get 3a minus 2 equals 3b minus 2. Simplifying this equation leads to a equals b. This proves that the function is one-to-one. Algebraic proof provides a robust method to confirm the one-to-one nature of a function by demonstrating that equal outputs imply equal inputs. Section 8. Practical applications of one-to-one functions. One-to-one functions have significant applications in various fields. In cryptography, for example, these functions are crucial for designing secure encryption algorithms. The unique mapping property of one-to-one functions ensures that each piece of plaintext information maps to a unique piece of ciphertext, making it difficult for unauthorized parties to decipher the message. In computer science, one-to-one functions are used in data structures like hash tables. These functions map data to specific locations within the table, ensuring efficient data storage and retrieval. The unique mapping property prevents data collisions, where different data points map to the same location, ensuring data integrity. Moreover, one-to-one functions are essential in data analysis and modeling. They allow us to establish clear relationships between variables, ensuring that each input variable corresponds to a unique output variable. This property is crucial for building accurate and interpretable models. These practical applications highlight the significance of one-to-one functions in various domains, extending their relevance beyond theoretical mathematics to real-world problem-solving. FAQs about one-to-one functions. Here are some frequently asked questions about one-to-one functions. Can a one-to-one function be its own inverse? Yes, it can be its own inverse. This happens when the function reflects across y equals x. Are all linear functions one-to-one? No, only if the slope is not 0. Can a function be one-to-one for a specific interval? Yes, it can be one-to-one over a specific interval. These FAQs clarify one-to-one functions. Section 10. Conclusion: Embracing the power of one-to-one functions. In conclusion, one-to-one functions, with their unique mapping property, play a vital role in mathematics and its applications. Their ability to establish distinct relationships between inputs and outputs makes them essential in areas like cryptography, computer science, and data analysis. By understanding the properties of one-to-one functions, we can effectively utilize them in various mathematical operations, ensuring data integrity, building secure systems, and creating accurate models. As you continue your mathematical journey, remember the power of one-to-one functions and their ability to bring order and clarity to complex relationships. Embrace the elegance and utility of these functions and explore the fascinating world of mathematics with a deeper understanding.